3 says that if vector D is negative 5 I hat plus 6 j hat minus 3 k hat, meaning it has negative 5 component on the x-axis plus 6 component on the y and negative 3 on the z, where I hat, j hat, and k hat are all unit vectors on x, y, and z axis respectively. Similarly, we have the second vector, vector E, is equal to 7 I hat plus 8 j hat plus 4 k hat. The first problem we are asked is to calculate D cross E, the cross product of D and E. This is going to be a vector too, since we know that unlike the dot product, for which the result is a scalar, if it is a cross product, our result is also a vector. So we will get a third vector, D cross E. B says find the angle between vector D and vector E. This means that probably vector D is somewhere here. This is where you have vector D, and then I have vector E here. For example, now the two lines meet at this point, they make angle theta here. The question is, what is the size of this angle theta? C, show that D cross E, this vector D cross vector E, we should show that it is perpendicular to both D and E, meaning it makes angle 90 degrees with D, and it also makes angle 90 degrees with E. So this means that this vector probably is somewhere here, up here, such that this is D cross E, such that the angle between D cross E and D is 90 degrees here. And then again, the angle between this D cross E and E is also 90 degrees. This way, it is perpendicular to both D and E, and we know the angle between D and E is theta. So, in summary, A says we should get the value of this vector, okay, D cross E. B says we should get this angle theta between D and E. And finally, C said we should show that this vector makes angle 90 degrees with D, and it also makes angle 90 degrees with vector E. Okay, this is the summary of what we are expected to do, and now let's start solving the problem. Okay, vector D cross vector E is equal to, okay, we open a bracket, then we take the I, J, K, I hat, J hat, and K hat. We write it in this way, I, and then we have the J here, and then we have the K here. Next, we start with D. We know that the I, the coefficient of I hat for D is negative 5, so we put negative 5 here. Coefficient of J hat is 6 positive, so we put 6 here. And coefficient of K hat for D is negative 3, so we write negative 3 here. Now we can go to vector E, since they say cross E vector, so we take 7 from here, then plus 8, so, and then plus 4. Okay, the next thing we are going to do is equal to, we open a bracket, we have to consider this column here as positive, this one negative, this one positive. Okay, with this I can say I have a bracket here. You open a bracket like this, then you put this I hat. Next, you take this negative sign, place it here, and then you open another bracket, and then you can put j, this j hat. Finally, you take this positive plus, you open the bracket again, close bracket, and now you can put your key hat. Now, the next question is, what am I supposed to write inside the three brackets that I just have? Okay, for the first one, since I have I hat here, I will have to ignore the column that has the I and the row that has the I. So if I ignore this one, it means I will be ignoring the negative 5 and 7. If I ignore this one, it means I will be ignoring IJK. So it means I will end up with this 6, negative 3, 8, 4. So I will write them here, 6 here, negative 3, and 8 here, 4. I will do the same thing for J. Under J hat, I will ignore this one and this one. If I ignore this and this, it means I will be using these numbers, negative 5, 7, negative 3, 4. So I will write them here, negative 5, 7, negative 3, and 4. Finally, for J, if I ignore this one and I ignore this one, I will have negative 5, 6, 7, 8. Negative 5, negative 5, 6, 7, 8. Next, I will say this should be equal to, I open a bracket here. First, I will multiply them diagonally and subtract. I will say 6 times this one minus negative 3 times this one. So 6 times 4, this is going to be 24, then minus negative 3 times 8 will be negative 24, and I have negative here, so the two negative will give me a positive sign, so I will have plus 24, close bracket, then I have my I hat, then I have negative again, open bracket, negative 5, this negative 5 should be multiplied by 4, and I have negative 20, and then minus negative 3 times 7 will be negative 21, and I have negative here, so the two negative will produce a positive sign, so 21, then here is J hat, then plus open bracket again, I have negative 5 here, multiplied by 8, this will be negative 40, then minus negative this one, 6 times 7, this is 42, so I have my K hat here. This is equal to 24 plus 24 is will give me 48 I hat, and then negative 20 plus 21 will be 1 positive, and I have negative here, so this will just be minus 1 I J hat. But if it is 1, you can omit the 1. If the coefficient of J is 1, we can omit the 1. We know that 1 is here, of course. Negative 40, negative 42 will be negative 82, and then plus here, plus minus is still minus, so I have minus 82 here, K hat. This is D cross E. We are done with A. We go to B. For B, how do we find the angle between the two vectors? Okay, this is how we should do it. With the magnitude of D cross E, the magnitude of D cross E is equal to the magnitude of D alone multiplied by the magnitude of E multiplied by the sine, not cosine, the sine of the angle between them. From here, I can make this sine theta the subject of the formula. So how do I do that? I will divide both sides by magnitude of D and magnitude of E. So this will mean that my sine theta equals what I have here entirely, D cross E, vector D cross vector E, divided by the magnitude of D alone multiplied by the magnitude of vector E. This is equal to, okay, how do I find the magnitude of D cross E? Remember, this is our D cross E here. So you simply open a square root. In the root, you take the coefficient of I here. The coefficient of I is 48. So you put the 48 and square it, plus the coefficient of J hat is -1. So I open a bracket here and place -1 close bracket square, plus the coefficient of K hat is -82. So I open a bracket and place -82 close bracket and square divided by how do I get the magnitude of D? Look at my D here. So I will take the coefficient of I, the coefficient of J hat, the coefficient of K hat. So this will be square root of the coefficient of I hat, as we can see, is -5. So open bracket -5 close bracket square, plus open bracket, or I don't have to open a bracket since it is positive. I will just say 6 here square, plus this is -3, so I must open a bracket, open bracket 3 close bracket square. This is the magnitude of D. Then multiplied by the magnitude of E. I will do the same thing here. That's my E. So I will say 7 square plus 8 square plus 4 square. Okay, this is equal to, okay, now I will take, now I will take my calculator. I will not press the square root. I will only evaluate what is inside the square root first. So I will say 48 squared plus, I will have to ignore the negative sign here because the square will cancel the negative sign. So I will only press 1 square and ignore the brackets 2 as well. Here too, this negative is cancelled by the square. I will only press 82 plus 82 squared. This is 9029. So it means I have square root of 9029 divided by, okay, for the next one, I have square root of this. So again, I will ignore the negative sign. I will only press 5 squared plus 6 squared plus 3 squared, and this will be 70. So I have square root of 70 multiplied by square root of then here this one, 7 squared plus 8 squared plus 4 squared, and this will be 129. Next, we move on. Next, I have square root of 9029. Okay, this is my numerator. For the denominator, since I am multiplying and these values are all inside a root, I will just put 1 square root and multiply the 2. So I will only say 70 multiplied by 129, and this will be 9030. Finally, I will now say square root of this divided by square root of this. So I will have square root of 9029 divided by square root of 9030. Correct to, I will record my result correct to 4 decimal places, 4 digits after the decimal point. So this will be 0.9999, very close to 1. Okay, once I get this one, I can now obtain my theta as theta equals sine inverse, then I open bracket and write all these 0.999 that I have just obtained. So this will be, okay, how do I press this one? To press this one, first of all, you must press this function shift. After shift, then you press this function sine. You will see sine inverse being displayed on the calculator. So I will press shift sine, and sine inverse appears. Next, I will write this 0.9999. So this gives me approximately, correct to 1 decimal place, 89.2 degrees. So the angle between vector D and vector E is 89.2 degrees. Okay, now for C, we should show that this vector is perpendicular to D and E. Okay, as I pointed out from the beginning, it means that we should show that this one makes angle 90 degrees with this, it also makes angle 90 degrees with this. But we don't have to find that 90 degrees angle. We don't have to do that. The idea we are going to use is that if I have a vector here, let's say I have vector A here is directed upward, and I have a vector here horizontal, this is vector B, and they make angle 90 degrees with each other. You see, this is 90 degrees. Then vector A dot vector B, meaning the dot product of the two vectors must be zero. Must be zero. This is always true. So it means that what we have to do is to take the dot product of this vector and this one and see if it gives zero. If it gives zero, it means this vector is perpendicular to this vector. Again, we take the same vector here, D cross E, and get its dot product with respect to E and see if it is zero. If we get zero, it means it is perpendicular to E. Then we conclude that this is perpendicular to both D and E. That's exactly what we are going to do now. Okay, I will have to clean this one to do that. For C, we said D cross E dot D first. We start with this one, and this is equal to our D cross E. This is what we obtain for D cross E. So we open a bracket and say 48 I hat minus J hat minus 82 K hat, close bracket. That's our D cross E. Then dot, we open a bracket again, vector D. For vector D, negative 5 I hat plus 6 J hat and negative 3 K hat. Now this is equal to Okay, for dot products, remember the result must not contain I, J, and K, the unit vectors. No, this is because it is a scalar quantity. So what we will do is we will take 48, the coefficient of I here, and multiply it by the coefficient of I here. So we will have here as 48 multiplied by -5, then plus, open the bracket again, the coefficient of j here is -1. We multiply it by the coefficient of j here, which is 6, plus the coefficient of k here is -82. We multiply it by the coefficient of k here, which is -3. You see? And at the same time, we ignored the I, J, K here. This is equal to, okay, since this is negative and this is positive, positive times negative, this will be negative 48 times 5. So press 48 times 5, and this gives 240. This means I have -240 here. Then -1 times 6, this will be -6 here. Plus times minus, so I have -6. Minus times minus, they cancel each other, so this plus stands, and I have 82 times 3. So I press 82 multiplied by 3, and this will give me 246. So this is equal to -240 minus 6 is -246. Then I have plus 246. Finally, -246 plus 246 should give me 0. Since the dot product of this vector and this vector gives 0, it means that they are perpendicular to each other. They make angle 90 degrees with each other. This means maybe this is what you have here, okay? And then here you have vector D. So the dot product of the two gives 0, which means D cross E dot D is equal to 0. That's the physical interpretation of what is happening there. Next, we want to also show that this vector is perpendicular to this one. So we'll take the dot product again. Okay, we'll take the dot product again. So we are going to say similarly, we can take D cross E dot E the dot product of this one and this one. This should be, okay, we got D cross E as 48 I hat minus J hat minus 82 K hat dot our E, this is our E here, so we write 7 I hat plus 6 J hat plus 8 J hat 8 J hat plus 4 K hat. Okay, as before, we'll take coefficient of I here and coefficient of I here and multiply them. So this will be 48 times 7, okay, and we ignore the I, plus open bracket coefficient of J here -1 times coefficient of J here is 8, plus coefficient of K here is -82 multiplied by coefficient of K here 4. So this is equal to, now we take our calculator and say 48 multiplied by 7. This will give us 336. -1 times 8 minus 8. plus minus minus, so I have minus 8. Then here, minus 82 times 4, so I'm going to press 82 times 4. This is going to be 328, but it's negative, so plus times negative is negative 328. Finally, finally, I will now take my free everything and say, okay, 336 minus 8 minus 328, and this will give me 0. So since the dot product of these two is 0, it means they make angle 90 degrees with each other. So summarily, what I do have is something like this. I have all the three vectors like this, such that this is vector D, for example, and then this is vector E, and this is D cross E. This is D cross E. The angle between these two is 89.2 degrees. And then the angle between D cross E and D is 90 degrees perpendicular, and the angle between D cross E and E is also 90 degrees. This is perpendicular to the 2, and then the 2 here makes angle 89.2 degrees. That is the solution we are expected to find, and thank you for watching. Assalamu alaikum.